So I'll start right at 7 o'clock, about a minute and a half from now. All right, Heather, can you give me a nod if you can hear me all right? All righty. Well, good evening, everyone, and welcome to the first of two virtual Meet the Astronomer nights that Dyer Observatory will be holding during the month of December. I'm Dr. Billy Tietz, and I'm the acting director and the astronomer here at Dyer Observatory. Helping us behind the scenes tonight, we have a couple of my colleagues, Helen Morissette and Alex Rockefeller. And then from VU News and Communications, we have Brian Smokler, who is making sure that our broadcast is going out to everyone tonight. So I want to extend a big thank you to them for all their help on this event. So before we get started, I just want to make a couple of announcements of some upcoming events that we have. So this Saturday from 7 p.m. to 9 p.m. Central Time, Dyer Observatory will be hosting its December virtual star party. We will have folks from the Bays Mountain Park and Planetarium, the Barnard Seaford Astronomical Society, and the Memphis Astronomical Society joining us. And even though the weather forecast doesn't look too terribly favorable for Saturday, you never know, we might get a few peaks at the sky, but regardless, we will still have a great evening. We'll be discussing a lot of different topics. We'll be doing some demonstrations. And of course, we're going to be taking questions from our viewers. So hopefully you can join us for that. The event is free and registration is not required. Next Tuesday, December 15th, we have our second Meet the Astronomer talk for the month. This will be given by Vanderbilt astronomer, Dr. David Weintraub, and it's very appropriate for this time of the year. His topic will be, Can Astronomy Explain the Star of Bethlehem? So if you've been to Dyer Observatory's Meet the Astronomer talks before, you may have seen this gentleman. He's a wonderful speaker, and we're really looking forward to having him back to do this really interesting talk. And so that talk was actually, or the impetus for that talk, I should say, was actually due to an event that we have coming up a little bit later this month. And Dyer Observatory will be doing a virtual event for that as well. So if you've been on social media or browsing the web, then you've probably come across a story or a headline about a great planet conjunction. Or you may have seen something about something like this hasn't happened in over 800 years. Well, if you go outside and look in the southwest just after sunset, you'll see a bright object, which is Jupiter, and you'll see a little object next to it, and that's Saturn. And if you've been watching these for the past few months, you'll notice that they've been growing closer and closer together. So when they get pretty close together, that's an event that we call a conjunction. Of course, that's just the viewpoint that we have from Earth. In reality, they're still very far apart. From our viewpoint, they look like they're right next to one another in our sky. So this great planet conjunction occurs on December 21st. And it's special because this is the closest that Jupiter and Saturn would have appeared together in our sky for about 800 years. This will be about a once-in-a-lifetime event for a lot of folks, because the next time Jupiter and Saturn will be this close together in our sky won't be for another 60 years. So we are encouraging everybody to go out and look at these planets, just naked eye, over the coming days, and watch them get closer and closer together. Now, on Monday, December 25th, if clouds permit, then we will be doing a live stream of a live view from one of Dyer Observatory's telescopes, because these planets will appear so close together that you can actually see them both in the field of view of a telescope at the same time. So it's very, very rare, and that's why this is so special. So again, that's going to be December 21st, 5 p.m. to 6 p.m. I'll be hanging around on that live stream to answer questions and kind of discuss what we are seeing. So all of these events that I've mentioned are free to the public. There's no registration required. And if you go to our website, dyer.vanderbilt.edu, and just scroll on down, you'll see more information about these events as well as the live stream link. So tonight, I am delighted to introduce our guest speaker. Dyer Observatory is part of Vanderbilt University's Division of Government and Community Relations. We're actually on the community relations side. Joining us tonight is one of our colleagues from another part of our division. Dr. Heather Bloemhard is the Assistant Director of Federal Relations in Vanderbilt University's Office of Federal Relations, and is responsible for coordinating the university's federal relations and advocacy activities. She holds a doctorate in physics from the New Mexico Institute of Mining and Technology, and a bachelor's of science in physics and astronomy from George Mason University. Dr. Bloemhard is trained in physics and astronomy and currently works in research and education policy. She has spent time advocating for astronomy as the American Astronomical Society John Bacall Public Policy Fellow, as well as supporting defense research policy as a Science and Technology Policy Fellow, sponsored by the American Association for the Advancement of Science. So tonight, Dr. Bloemhard will be discussing how federal policy influences our relationship with so many things that are space related. So as we go through our talk tonight, if you have questions that come up, please put those questions into the chat box on YouTube. And when we reach the end of the talk, we'll have a question and answer session, and we're going to try to get to as many of those questions as we can. So without further ado, Dr. Bloemhard, thank you so much for joining us. We are so excited to have one of our own here tonight, and I'll turn the program over to you.
Thanks, Billy. I am going to try to share my screen, and as I do that, I really appreciate the opportunity to talk with you all today. Space policy is an area of kind of fascination of mine. It's started with my time as an astrophysics graduate student, developed as I worked with the American Astronomical Society, as an advocate for the astronomical sciences, and has really continued. I currently serve on AAS's Committee on Astronomy and Public Policy, and just have a really deep continued interest in the subject. Can I get a quick, from my friends over at Dyer, can I get a quick thumbs up that we've got my slides shown on the screen? All right, I think we are okay. Perfect. Before I jump into the topic, I do want to give a quick caveat here. While I am a lobbyist for Vanderbilt University, and we do have some space policy topics that we lobby on, specifically when it comes to space science research funding agencies and really advocating for robust funding for agencies like NASA. A lot of what I'm going to talk about here doesn't intersect with where Vanderbilt has a policy position. So it really should just be considered information that I'm sharing with you, my opinions, not affiliated with Vanderbilt University. Now, jumping right in, this image that I've had here on the title slide that you are looking at is from a location that if you're from Tennessee, you might be familiar with. It was taken at the Pickett State Park and Pogue Creek Canyon State Natural Area. This is a park that was designated a dark sky park. It's a silver tier international dark sky park, designated so by the International Dark Sky Association in 2015. It is considered to be one of the few remaining dark sky locations in the state of Tennessee, and in fact, east of the Mississippi River. It's considered rural sky, which means that you can observe some of the brightest Messier objects like M33, the Triangulum Galaxy, M31, the Andromeda Galaxy. You can observe the Central Galaxy's complex structure and zodiacal light. It also means that there's light pollution on the horizon. At this particular location, you're going to have Nashville to the southwest and Knoxville to the southeast. Now, I mention this because light pollution is one of the policy areas that astronomers really care about. Why do they care so much? If you look at a map of the contiguous 48 United States, this actually bleeds over into Canada and Mexico as well. You see this map of, it's a map of the light pollution, the ground-based light pollution that we're all kind of surrounded by. And you can see these bright spots that are overlapping with population centers. There are, in some of these states, actually in 18 of the states, plus the District of Columbia and Puerto Rico, laws in place to help reduce the light pollution and try to preserve some of the dark sky areas that we see here in the western half of the country. Most of these laws are at the city and state levels, and a lot of them are related to kind of outdoor lighting fixtures that might be installed on state-operated buildings or on roadways. I'll note, Tennessee does not have any such laws on the books that I'm aware of. And it's my opinion that the state and local levels are really the right place for these sorts of discussion. This isn't one that we're going to get to a policy discussion on the federal level. Where we start to get into federal policies when it comes to light pollution is space-based light pollution. Now, what do I mean? Has anyone had the experience of viewing the International Space Station as it passes over your location? If I remember Dire social media correctly, the International Space Station actually passed over yesterday in a pretty spectacular way with the conjunction that's becoming more prominent in the night sky. Well, if your goal is to observe the naturally occurring phenomenon in space, then the International Space Station is light pollution. Now, in the 22 years that ISS has been in orbit, the number of human-made objects in space has increased pretty dramatically. This is a star chart for tonight at just before midnight at that location, that dark sky site that I showed at the beginning of my presentation. You're going to see a lot of features that might look familiar if you're used to looking at star charts. We have the outlines of constellations. There's the planets that are here. And you've got actually Jupiter and Saturn practically on top of each other in this star chart because of that conjunction that Billy has mentioned. And then you have all of these green dots. Now, what are these? These are Starlink satellites that are illuminated and above the horizon. And at this exact moment in time that I took this star chart, there are 434 of them visible. Now, just because they're there doesn't mean that they're a problem. Moving on to this image that was taken from the Cerrero Tololo Inter-American Observatory, which is a telescope that's run by the National Science Foundation based in northern Chile. The astronomers did what is a pretty standard practice for the science of astronomy, and that's taking a long exposure. It's a similar concept to how if on your cell phone you set your camera to night mode, And you have to hold yourself really steady to make sure that you're capturing the image that you want. You're basically letting the camera collect more light so that it can get a clear image of the thing that you want. Well, if you're taking that image and you're trying to hold steady, but your cat zips in front of your camera, your cat's going to look a little bit like a streak. That's basically what's happening here. They're not cats, of course, but they're satellites. This is a 5-minute exposure taken with this telescope, and the streaks, these lines that you're seeing run diagonally across the field of view, are Starlink satellites. And so from an astronomer's perspective, we would say that you can't really deny that there's going to be some sort of an impact on our ability to do science. The question really is, for policymakers, is this a problem in need of a policy solution? And if so, what does that policy solution need to look like? As I kind of talk through this a little bit, I'm going to try to play this video. Looks like it's going. What we're looking at here is a simulated view of the night sky once all 12,000 of the Starlink satellites are in orbit. I mean, what we're hopefully going to be able to see are these pinpricks of light that are moving quickly across the screen in all directions. As you're watching that, I'm going to talk a little bit about what Starlink satellites are trying to accomplish. Starlink satellites are low Earth orbit communication satellites being launched by SpaceX. The goal for Starlink is that it will provide very low latency internet access across most of the inhabited areas on Earth. And because they want to cover such a large area, SpaceX is planning to launch around 12,000 satellites. Now, I should be clear, SpaceX isn't the only company that's trying to do this kind of work. There's a project by Amazon called Kuiper that's doing very similar sort of work. It's planning to launch about 3,000 satellites. There's a company called Telesat that aims to launch a couple of hundred. And until very recently, there was a company called OneWeb that was also planning to launch these sorts of satellite constellations. They actually have launched some satellites in 2019, but they declared bankruptcy in March of 2020, and I'm not 100% sure what their future plans are at this point. At the beginning of 2020, when you assessed all of the satellite internet proposals, and you counted up all of the satellites that were planning to be launched, that would mean that we would end up with around 50,000 active satellites in orbit within the next 10 years. Now, again, it doesn't mean that this is a problem in need of a policy solution. Part of where policymakers are starting to get involved in this conversation is related to a decision that was made by the FCC. The decision was made in 1986 that communication satellites would be exempt from what's called an environmental assessment. Environmental assessments are basically assessments to understand the impact of a particular project or proposal on the environment. And in 1986, the barrier to getting a satellite into space was so significant that the FCC decided this isn't something that we need to put companies through. It's going to be so difficult that it'll be few and far between that this ends up being a topic of concern. However, with all of these proposals, this is really starting to change. And so a couple of senators, Tammy Duckworth from Illinois and Brian Schatz from Hawaii, have asked for the Government Accountability Office to re-examine this decision and really ask the question, is this an appropriate decision given the relative ease of access to space for commercial launch industry? I know that there was a law student at Vanderbilt who wrote a paper arguing that this categorical exemption at the FCC was inappropriate. Astronomers in general are trying to partner with the companies to find solutions that are going to work for everybody. The American Astronomical Society, I know, has convened a workshop to assess the full impact of the satellite constellations. and to start to develop some recommendations for how to mitigate any harm that constellations might do to astronomy. In the meantime, these companies are still applying for licenses, and actually in July, the FCC did authorize the Kuiper's satellite constellation, and as far as I can tell, without the need for this environmental assessment. There have in astronomy been similar debates that I'll get into shortly. It'll be an imperfect analogy, but hopefully it can help to illustrate how it's possible to balance the interests of the commercial sector with the interests of the scientists. Now, because my background when it comes to space policy really focused on astronomy, I tend to start from that perspective. And another key topic for astronomers is federal support for astronomical facilities. Got here some pictures of some recent and upcoming astronomical facilities. We have OSIRIS-REx, which is an Explorer mission to the asteroid Bennu. This is actually a computer rendering of the Explorer with the asteroid. Next to that is the James Webb Space Telescope. This is while it is in fabrication. And then on the far side, we have what is now known as the Vera Rubin Observatory in northern Chile. All of these were at least partially funded by the United States government. And that's another major way that policymakers impact astronomy. It often comes down to having necessary resources to allow for the construction, launch, and operation of these facilities, as well as making sure that there's an ability to plan for the next generation of facilities. But there's more than just some money when it comes to policy that these observatories and facilities are going to care about. At the Vera Rubin Observatory, they're going to be very concerned with the light pollution from satellite constellations that I mentioned. This is a project that's in Chile, so that obviously means that there are international implications. There's a diplomacy aspect to this. It's also getting funding from international partners. So there's that piece of it that brings in the international science and diplomacy aspects of policy. The James Webb Space Telescope is another international undertaking. So there's also those policies that they need to work around and think about. They don't have to worry about the light pollution from satellite constellations because James Webb Space Telescope will be in orbit beyond those constellations. They have recently had to worry about policy surrounding how NASA works with contractors. And OSIRIS-REx isn't collecting photons the way that Vera Rubin and James Webb will. It has collected a sample from the asteroid Bennu and is now on its way back to Earth, which raises questions around a topic known as planetary protection. And I'll talk more about that shortly. But before I do, I want to take a moment and really make it clear that astronomy is just one small part of space policy. To get a better idea of the full scope of space policy, let's look at the whole space economy. The global space economy is currently estimated at around $344.5 billion. Around 3/4 of that is the satellite industry that I mentioned at the beginning of this presentation. That includes television, there's the communication satellites, there's some GPS satellites, there's the launch services. The remaining 1/4 or so is the non-satellite industry. Because I'm sure that some of you might be interested in this. About $1.1 billion of that is the commercial human spaceflight sector. The rest of it is government budgets. About 2/3 of the government budgets is the US government budget, with a portion of that being NASA. We also have several agencies at the Department of Defense and NOAA that make up the US government's space economy. All told, when you crunch all the numbers, astronomy is a fraction of 1% of the global space economy. So what are the rest of the people who think about space policy really thinking about? One of the topics is frequency allocation. This is a big topic for the satellite industry, and it's a very big chart that I've tried to fit on a very small screen. The result is that you probably cannot read what's happening here. I'm going to zoom in, so don't worry about trying to really understand the different colors that you're looking at right now. What I want you to notice first and foremost is the variety of colors. If you look over on, for me, it's the left-hand side, you have a legend of what all of the colors mean. Again, too small to read what those words are, but you can probably count that there are 30 different colors here. There are 30 different uses for spectrum that we need to contend with when we're talking about frequency allocation. One final piece that I'll point out is the range we're talking about here. The radio spectrum covers 9 kilohertz at the very top to 300 gigahertz at the very bottom right corner. I'm going to zoom in right at this portion here. That is roughly 4.8 to 8.1 gigahertz. And I picked this area because you can get a pretty good understanding of how close together some of these wave bands are, how mixed together the various uses are. And I'm going to call out a few in particular. Here in the bright yellow, we have a radio astronomy band. Moving down in this sort of orange color, and I guess that's kind of a salmon pink. We have some wave bands for space research and Earth exploration. And then moving down even further, the brown is meteorological uses. What that means is that this particular wave band between 4.99 and 5 gigahertz, that is dedicated for the use of radio astronomy. There is not supposed to be any communication satellites, any GPS satellites that are transmitting in this wave band. That said, you'll notice that it's right next to a mobile wave band. And let me remind myself what that is. A couple of navigation bands as well. So there is some concern for radio astronomers that there will be leaking from those other bands into the radio astronomy band. And that leaking creates noise in the data, which makes it more difficult to have reliable scientific results. This was less of an issue before the demand for wireless broadband started to soar. But as 3G and 4G mobile services became more widespread, and now moving into 5G, of course, it started to be more of a concern for radio astronomers. And even within some of the communities who want to use frequency for some of these other purposes, the communications and the GPS purposes, there's still some concern about the chances of interference. So how do you handle that from a policy perspective? Let's start out with a foundational principle that policymakers agree with. Radio frequency is considered by most countries to be a national resource, similar to land. And like land, it can be sold to private entities. Again, similar to the sale of land, that sale of spectrum can come with stipulations about the use of land or spectrum. For example, the sale can require that the entity buying the spectrum use technology that limits radio spectrum pollution. The FCC manages spectrum in the United States, and so it's their responsibility to place any of those stipulations on whoever might be buying various wave bands of spectrum. And of course, because spectrum doesn't have an international border, there are a lot of policy discussions about how we harmonize how various countries allocate their spectrum. But as I mentioned, as I previewed earlier, what I'm really hoping this example highlights is that it was possible to balance the competing interests of astronomers who took some care to define the specific problem, which in this case were the weak signals coming from contamination from other wavebands. And policymakers were able to define a narrow policy solution to help them address the problem without overburdening the commercial sector. I'll admit that this is an imperfect comparison to the satellite constellations, but I'm really hoping that it helps illustrate how policymakers can approach balancing the interests of commerce and science. Another topic that is of great importance to the global space economy is space traffic management. Humans have been launching objects into space since 1957. There are currently more than 500,000 artificial objects reported in orbit, and that includes the couple of thousand operational satellites that I mentioned before. Now, these artificial objects are really just objects that are large enough to be tracked. The tracking of those objects has been a core part of what's known as space situational awareness, which is a field that the Department of Defense really pioneered. There have been for a couple of years ongoing discussions about what the most appropriate civilian home is for space situational awareness and space traffic management. As more and more commercial entities have been getting involved in space launch, it started becoming clear that the Department of Defense being the only home for these topics was no longer appropriate. So to try to assess the appropriate home, Congress commissioned a report on the subject, and that report was released this past summer and indicates that the Department of Commerce is probably the best home for such an agency. A couple of senators have actually proposed a bill that would transfer this responsibility to the Department of Commerce officially. And from our perspective, there's some urgency to making this happen, because every year there are more objects that are launched into space. And we're expected to be at a rate of around 1,100 objects launched per year by 2025. Now, let's just be clear, there is a lot of space in space, but that's a lot of stuff too. And that 500,000 number that I mentioned earlier, a lot of that is debris that can't steer and so could become a hazard to operational satellites. So what we have is this very busy area in orbit around Earth of objects that can't steer, with operational satellites that are critical to some business or other. And everybody's trying to figure out how do you really direct this traffic? It's a fact that the risk of collisions between objects in space is very real, and that major collisions have occurred. It's also a fact that one collision can produce a dangerous debris field that now poses a hazard to yet more satellites. And of course, damage to an operational satellite has some financial consequences to the owner of that satellite, but perhaps more importantly, it also endangers global communications, navigation, satellites that we might be relying on for any number of purposes, as well as it poses a danger to astronauts in space. So part of why there's some urgency to find the civilian home for space traffic management is because that home agency would be empowered to draft regulations to put in practice to lay out some new standards of practice. One example of a new standard of practice that could be put in place is just better orbital hygiene, better practices when it comes to how you deal with debris. Do you slow the pace of launch until objects deorbit? Do you require satellites that are nearing the end of their operations to move to some outer graveyard orbit? Do we just have to wait to solve this problem until technology advances to a point where it becomes cost-effective to remove or remediate those defunct satellites? That last piece raises its own legal questions around ownership, because if company A tries to go remediate company B's satellite, are they engaging in theft of property? Or how is the law really going to hammer out these questions of ownership? It's important that this is another area we keep in mind, the international aspect of all of this, because of course the United States is not the only country that is launching satellites into space. The European Space Agency actually, I think it was last week, they made an announcement that they are working on a project to capture and dispose of a piece of space junk. So that's going to help move the technology along, and maybe we can learn something from their efforts that will help us in the United States figure out how to manage space traffic. Another topic is planetary protection. I mentioned this when I talked about OSIRIS-REx mission. Because what this is really a set of principles that in the design of an interplanetary mission, where we're trying to avoid any biological contamination of the target celestial body and of Earth. The basic mantra here is leave no trace. From the perspective of science, we don't want to bring our microbes to space, because how embarrassing would it be to discover life on another planet only for it to have been your own contamination? There's also a possibility that any contaminating microbes we bring might thrive on that planet, and now we have a situation of an invasive species potentially even choking off the native life that might possibly be out there in the galaxy. So NASA, actually, this is another one with international science components to it, and the United Nations, with their Committee on Space Research, has really created this international practice of planetary protection. Within the United States, NASA is responsible for implementing these policies, and they actually, this past summer, you may have seen the news that they revised their planetary protection policies related to the moon and one related to Mars. Part of this is because of increased interest in exploring the moon and Mars from both NASA and the commercial sector. So they wanted to try to get their ducks in a row and make sure that the policy was going to be prepared to handle that increased possibility for increased activity. This image that I'm showing here is actually the Viking probe undergoing decontamination. Now, those are some of the more well-established policy areas. I'm going to talk about a couple that are more emerging policy areas. Asteroid mining in particular. Asteroid mining, kind of like it sounds, is the exploitation of raw materials from asteroids and other minor planets, including near-Earth objects. Now, legally, nobody can own an asteroid, but the US Space Act of 2015 allows US companies to own the materials they mine from bodies in space. There are still a number of engineering challenges that have to be overcome before asteroid mining could become feasible, let alone profitable. But there are people who are asking questions about the ethics and our philosophy and regulatory approach to managing the resources available on these asteroids. The questions that I ask on this conversation are, do we want to carry over our Earth-based approach to mining into space. When we did this on Earth, we ended up having to deal with some massive cleanups, and we're really still not done with all of that cleanup yet. Some of the policies that we enacted to try to help with that cleanup are the Clean Air Act in 1963, the Clean Water Act in 1972, and the Surface Mining Control and Reclamation Act of 1977. All of these were in concerns to the environmental, in response to the concerns that the environmental effects humans were having on Earth. And of course, there's some discussion about additional legislation for the Earth-based environmental concerns that we're dealing with. So as the reality of asteroid mining starts to become clearer, how do we approach the mining of those resources so that we don't perpetuate some of these same problems that we caused here on Earth? Now, they weren't all negative. There were some benefits that some people can highlight. But I think that it's a good practice to try to learn the lesson of history and at least ask the question how we're going to approach things in the future. Another topic where I think it's important to ask these sorts of questions about our philosophical approach is exploration. There's a lot of historical evidence for the drive within humans to know where they are, to really understand our surroundings and to find those boundaries and then push those boundaries. And that motivation is at the core of a lot of our exploration. And it's certainly what has historically motivated NASA. NASA likes to say, we reach for new heights and reveal the unknown for the benefit of humankind. For example, NASA is planning to return humans to the moon, and there are longer-term plans to bring humans to Mars. Pictured here is actually Curiosity on Mars. And we also know that SpaceX is planning to establish a human settlement on Mars. And all of this is generating a fair amount of justified excitement with the possibility of human settlements on Earth. On the flip side, these kinds of activities have been likened to colonization, which again, looking historically, is the reality of how some humans push their boundaries to include other territories. Now, I've included here a screenshot from the home screen of the Oregon Trail computer game. Mostly really, because even though I didn't really appreciate it at the time, it's my first memory of learning about this kind of exploration and colonization here on Earth. It's the perfect example of how people decided to leave where they were from and set off in a new direction. They had to make decisions about learning about their path, traveling that path, and then along the journey, make decisions about how they were going to protect their family and try to accomplish their goal. So I think it's worth kind of asking questions about what is that goal? What do we want that goal to look like? Some of these questions we're going to have to answer in advance, because when you're en route to Mars, it's going to be a little too late to try to identify additional resources, set in place various ethical frameworks and other things like that. Some of the other people who are thinking about this topic, they advocate for establishing various operational norms, sort of a space ethics framework. The proposal that I like best suggests that we should embrace a stewardship of the space environment, that we should ensure that human rights of those endeavoring into space, that those rights extend to any civilization in space, that there's a rule of law as we undertake these ambitious projects, and that the benefits of space can broadly benefit humanity while motivating and rewarding those who take the risks and make the inventions and provide the investments to make all of this possible. Now I'm wrapping up now. I have a couple more slides, but I haven't been monitoring the chat, so hopefully we've had a lot of questions that we can get to shortly. I want to summarize some of the US federal agencies that are at play here when we talk about US space policy. We have, of course, NASA, which is responsible for enabling the safe, reliable, and cost-effective commercial spaceflight capabilities and services for the transport of the crew and cargo to and from the International Space Station. We didn't spend a lot of time talking about NOAA, but NOAA's role is really when it comes to the licensing of commercial remote sensing systems. Think of weather satellites that are owned by companies. They have to be licensed to collect that data, and NOAA is responsible for managing that. We mentioned the FCC and their role when it comes to frequency allocation, as well as with satellites and environmental assessments. We didn't talk too much about the FAA. They have a pretty significant role when it comes to commercial space transportation launches and reentry licensing requirements. And then the Department of Commerce has a relatively new office called the Office of Space Commerce, which is the main unit in charge of basically space commerce policy. And then, of course, not pictured here are the White House and Congress, both of which have undeniable role in making federal policy. I hinted at some of the other stakeholders in the US government, but just to be clear about who I'm talking about, we have the National Science Foundation, which operates the federal government's ground-based observatories, most of them. And then we have some agencies within the Department of Defense, the newly formed United States Space Force. We have the United States Space Command, and then we have the United States Intelligence Community, which has various satellite assets that they maintain as well. And lastly, I talked throughout this presentation about the role of international cooperation. So to lay it all out, the treaty that is really here to create the legal framework for international cooperation in space, it's a fairly long title. It's the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies. To put it shortly, it's the Outer Space Treaty. This map here shows in green the countries that are parties to the treaty. As of June, there were 110 of them. Not all of them have space programs or industries, but they likely have aspirations for that. In yellow, we have signatories to the treaty, and then in red are non-parties. Some of the key points of the treaty are preventing placing nuclear weapons in space, limiting uses of the moon and other celestial bodies to peaceful purposes, and so on. There are a couple of other treaties that get involved depending on what aspect of space you're talking about, and I can go into that if there are questions. But I think at this point, I will turn things over to see what questions we have in the Q&A.
Alrighty, Heather, thank you so much. That was an excellent talk. We do have a few questions. So the first one is the radio astronomy band based on an optimum spectrum to pick up signals from space, or is it a random assignment?
It's going to be based on the optimum spectrum to get signals from space. That's exactly what it is. And some of those bands are, there's a lot of bands where you can get radio signal from, as we saw from that chart. But the radio spectrum bands tend to focus on the ones where there's scientifically interesting information.
Okay. Would all space junk eventually fall to Earth, or could it orbit indefinitely?
This is a question that can kind of vary a lot on the physics of the orbit that object is in. A lot of times the orbit will decay and it'll fall into Earth's atmosphere, and sometimes it'll burn up if it's of a big size, or depending on the material it's made out of, it might make it to Earth's surface in one form or another. Other times, orbit indefinitely is a little harder to say because there is still drag that the satellite experiences. And so while it might orbit for a really long time, it's not going to go for forever and ever.
Gotcha. And that also puts me in mind of, there was an announcement recently that I think it was back in August, NASA had detected an object that when they figured out the orbit, they thought that it could be actually a booster rocket that was used to launch Surveyor 2 back in 1966. When
yes.
When it launched and the rocket body basically went out into the solar system into an Earth-like orbit, it ended up, we eventually crossed paths again and it passed by Earth again. So
yeah, I saw that article too. And I think that's one of the topics that's kind of being explored on ways to try to clear out some of the space debris. Could we nudge some of that debris so that it leaves Earth's orbit and maybe takes a wider orbit so that it's not occupying space that operational satellites could be using? But then if you do that, you might run into a very similar kind of problem that you just described.
Gotcha. Okay. Do you find international space policy to be more successful when formed between select individual partner countries or when instituted on a broad basis like through the United Nations?
That is an excellent question. This is sort of a question of, do you go top down when you declare policy, or do you try to grow a policy organically from the bottom up? And not speaking specifically about international space policy, but in general, the kinds of policy making that I see as being more successful are ones where there's a meeting in the middle, where there's an organic growth from the ground up of stakeholders who are identifying a need for a policy, and they all come together and form some agreement on what a policy should look like, and they convince people from the top what the problem is, what the policy solution should be, and then they can kind of try to meet in the middle on that policy. And that, from what I've seen, that creates a good base of stakeholder support, so that it's not like you're being forced to comply with this thing you have no agreement with. You were maybe part of the crafting of that policy.
Gotcha. So kind of like saying the one group says, hey, we have this really big idea, and then the other group says, hey, yeah, that's a good idea. Let's all work on it together.
Yes, exactly. Create that sort of a coalition of similarly minded people. Yeah.
Gotcha. So how is light pollution treated internationally? Are there any non-US companies which are planning satellite constellations, or will US legislation cover most of this activity?
So this is going to be something that right now, as far as I can tell, is handled nation by nation. Telesat, I believe, is not a US company. I think it's a Canadian company. So any US legislation isn't going to cover Telesat's contribution to satellite constellations, but there are almost certainly international conversations happening. Similar to how in the United States, we have the American Astronomical Society that's leading a lot of the astronomers here. At the international level, there's the International Astronomical Union, and they're going to be very active in having these conversations at an international level. The International Dark Sky Association that I mentioned at the top of this presentation, they are also going to be very involved in a question like this. I'm assuming that. I actually am not 100% sure that's true, but they work on an international level as far as I can tell. And so this might be something that needs to have several solutions within various countries, and then they can come together and create an agreement for how they're going to deal with this in collective.
Gotcha. And hopefully everybody else will jump on the bandwagon and
hopefully.
Let's see. Are frequencies actually owned, or are they licensed for use? Are there any regulations on who can limit, or excuse me, on who can own a frequency and what it can be used for?
So frequencies are licensed. And yes, there are ways that the FCC can place requirements on who can license a specific waveband, or on how they can use that waveband. And that comes, that's all set when the FCC announces their auction for the particular waveband. They will place the requirements on who can place bids and and for what purposes. Yeah.
Okay. Just a couple more questions here. What is the best way to support the reduction of light pollution in Tennessee?
So I would start by looking to see how your own home is lit. There's something about humans where we think that bright equals safe. And so what often happens, what I know my childhood home was like, is that there were a couple of really bright floodlights to try to illuminate the area around the house so that we could, feel like we could see where everything is, what's going on in the yard. That's not necessarily true. It is just as possible that someone or something that you don't want in your yard could be kind of hiding in the bright spot of that light. So there's actually you would be better served by having a dimmer light in your yard, something that cast just enough light so you could see what there was without providing a kind of a free hiding spot for, I don't know, that mountain lion that you want to know is out there before you go out there. There's also, you can put kind of shields on your lights so they don't direct the light upwards. They focus all of their light down. And then once you've taken care of your own home, you might look to see if you have options to ask your homeowners association to do similar things for your neighborhood, or there's another neighborhood governing body that you can talk to and kind of work your way out from neighborhood to city to county, and see how far you get, see what obstacles you might come across. This is an area where I know the International Dark Sky Association has a lot of resources to help people. So I'd also point you there. And you might, if you're finding that your own arguments about astronomy aren't holding all the weight you want them to, check to see if there's a tourism reason. There are a lot of areas where the dark sky is appealing to tourists, when tourism becomes a thing again after the pandemic finishes. So you can, again, try to find that coalition of people who agree on the core thing you're trying to accomplish and see where you end up.
When we were redoing the lights at the front of our neighborhood, and I was on the HOA board, that's one thing that we were concerned about, was making sure that the lights that we used were, really good at protecting the dark sky. We weren't putting in a tremendous amount of lights, but still every little bit helps.
Yeah.
Like up here at Dyer Observatory, when we were actually adding some of the lights out in our parking area, we specifically wanted to focus on making sure that we were focusing like where we needed it and only where we needed it. And when we weren't here, we were making sure we were as dark up here as we could be, so that, you know, we're surrounded by Radnor Lake. There are owls, other critters out there that require the dark or are used to the dark to live their lives. And so that's another thing to think about is, you know, what effect are you having on animal life out there that you may not think you're affecting, but, you know, owls and things that require that dark to get their prey.
Yeah.
You know, you could be really messing them up just by putting lights out there that are just kind of fanning light out into the yard. So
That's an excellent point. Conservationists can also be a good ally on this sort of topic.
Let's see. Can satellites be coated with materials like Vanta black or low albedo materials to limit reflectivity?
So limiting the reflectivity of the satellites is one of the recommendations that the American Astronomical Society has made to the commercial sector when it comes to these satellite constellations. I will admit I don't know enough about the technology and materials options to know what the best solution is, but there are ways that you can reduce the reflectiveness of the surface, and that would help address this question. Yeah.
Yeah, I think that when the first issues came across with the satellites that they were seeing launched by SpaceX, I think then SpaceX tried to recoat some of the satellites as an experiment, but unfortunately it didn't do much good. But, you know, hopefully they're still at the drawing board to really help reduce that.
Yeah, as far as I understand, SpaceX in particular is being very responsive to the concerns of astronomy. They might not be doing absolutely everything the astronomers might want, but they're trying to figure out how to strike this balance.
Right, it may take some time.
Yeah, it's going to take some time.
I think we have one question left. So how often are frequencies auctioned by the FCC? I would imagine that the periods between auctions are the best times to propose changes to the FCC considerations.
So I actually don't know how often frequencies are auctioned. I know that the last auction that I remember was when it's kind of a convoluted story. It's connected to when Congress passed the Bipartisan Budget Act, which put in place spending caps for some of this federal spending. And then after that, Congress said, that's not quite enough money to accomplish all the things we want to accomplish, so we need to raise the cap. To try to offset some of the cost of raising that cap, they instructed FCC to auction spectrum, because the funds that are collected from auctioning spectrum go to the Department of Treasury. You also raise an interesting point about the periods between auctions being the best time to propose changes. And I don't know the answer to that. So I'm gonna have to leave that one hanging.
Okay, no problem with that. I believe that is actually the last question that we had. Just checking one more time here to make sure. No, I believe that's the last one. Well, Heather, thank you so much. I have learned so much tonight, and I know that our audience has well. It's been a pleasure to have you as our guest speaker, and I hope to have you back in future Meet the Astronomer lectures.
That'd be great. I'd be happy to talk some more about all this. Thanks so much for hosting me here.
All right, thank you. So just as a reminder to everyone that was watching tonight, be sure to check our website for the upcoming events that we have for the remainder of this year. We have all of our links and information on there. And if you have any other questions, especially if one comes to you a little bit later on tonight, feel free to email me and I can forward it on to Heather or put you in direct contact with her. So thanks again to everybody, to Heather for a great lecture, to Helen Morissette and Alex Rockefeller and Brian Smokler for helping out with this as well. So hope to see you all this Saturday for our star party or next week for one of our other events.